So here we have domain restrictions based on the trig functions and their denominators. So we have in the denominator here 1 minus sine. So in this case, sine x cannot equal 1. Well, if I take a look at where sine x is equal to 1, sine x is equal to 1 at 90 degrees and repeating at 90 degrees. So x cannot equal pi over 2 plus n2 pi, okay, where n is an integer. So every 2 pi, every time it hits the top of the circle, we end up with a restriction. For the number 6, we have two restrictions. One is the tan itself has a denominator of cosine. So cosine cannot equal, we cannot have cosine x can't be equal to 0. Okay, so what that means, and tan has a restriction, has vertical asymptotes at pi over 2 and negative pi over 2, and it repeats itself. So x cannot equal negative pi over 2, pi over 2, dot, 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 dot. So we're going to write that as pi over 2 plus n pi. Okay, so the restriction repeats itself every pi, every half circle. Okay, if I have to draw that out, cosine is 0 at these two positions. We also have another restriction where the denominator cannot equal to 0. So we have another further restriction of tan x cannot equal to 1. Well, where is tan x equal to 1? Where does it have a slope of 1? It's going to be at 45 degrees and 225 degrees. So x cannot equal pi over 4. And this again has a repetition of pi, or every half circle. So then we can just write this as n pi.